Hey, good morning, everybody. This is Mr. Brooks. I'm making a video on solving, and we're going to get started with vocabulary so we can use the same language when we talk about this, okay? So I want you to learn one-step and two-step equations. These are different, and I want you to be able to recognize what type of equation you're doing so you can think about how you want to solve it. And this is going to go by the number of operations we're going to have to do. This takes one step, so there's one operation. This takes two steps, so there's two operations. An expression is a group of terms together. An equation is that same group of terms with an equal sign in it. You can solve equations, but you can't solve expressions. You can simplify expressions, but you can't solve them. A term is anything separated by a plus or minus, or it's also a number, and it consists of a variable and a coefficient and an exponent. The variable is the letter. It's a placeholder for an unknown, or it's a substitute for a number. A coefficient is the number in front of the variable, and that tells you how many of those things you have because you're multiplying it. The inverse operation, this is how you solve an equation, and so it's two operations that cancel each other out. So for example, the inverse of subtraction is addition, and the inverse of multiplication is division. Like terms are sets of terms that have the same variable and exponent, and so you can put them together. You can add unlike terms, but you can't put them together, whereas like terms, you can simplify it into one term. Okay. All right, so here's terms. So for example, 2x is a term and x is a term. And these two terms are like because x. 2 is the coefficient, x is the variable. There's an exponent of 1, but we don't write the exponent of 1. It's just given. And so because these are alike, 2x plus x, you can combine them. And this is combine like terms. Okay? And then down here we have another one. We have two terms again. They both have x, but this time this one has an exponent of 2. This one has an exponent of 1. And because these two are not similar, or they're not alike, then you may not combine them because you may only combine like terms. So you can still add them together. The answer is 2x squared plus x. You did not combine them. Okay, so let's look at one and two step equations. Here's one step equation, x plus 3. Here's two step, a number divided by 2 plus 3 is equal to 9. With this one, you might be able to do it mentally in your head, but I want you to be able to know what you're doing, okay? And it comes down to inverse operations. Okay, so in this case, it's x plus 3, and I'm looking on the side of the variable. I'm not looking on this side. Yes, I have negative 12, but all I want to do is get the x by itself. So I want to get x down here by itself. That means I have to take away, or I want to cancel plus 3. The inverse operation of plus is minus. I'm going to do it to both sides of the river because I always do everything the same on both sides of the river. Okay, if I multiply or divide or subtract over here, I have to do the same thing over here. And I don't even have to do any math. All I have to do is say plus 3 and minus 3 are inverse, they cancel, and I'll bring down the x. So this x is going to come down. Negative 12 minus 3, this is not 9. If you think about a number line, you have negative 12 on the number line. You're subtracting 3, so you're going this way. Okay. You're going to get to 12, 13, 14, 15. So this is negative 15. That's my answer. Negative 15 plus 3 is equal to negative 12. This is two-step. I've got one thing here, and I've got one thing here. So here's why it's important. Because here I can use mental math, and here I need to know which to do first. I see plus 3, so I know I'm going to have to minus. And I see divide by 2, so I know I'm going to have to multiply. But what do we do first? First off, I'm not going to do anything with a 9 because all I'm trying to do is cancel out the two terms on the side of the x, okay, or the two numbers on the side of the x. And in this case, I'm going to go reverse PEMDAS, or I'm going to think about it this way. I'm always going to add and subtract first. And I say that always with a caveat. I'll explain that in a minute. But I want to add or subtract first, or you can think about it as this x has the 2 and this doesn't have the x. So you want to do the term without the variable first. Do this term without the variable first. So I'm going to minus 3 first. Draw a line. That cancels. Remember, I don't need to write 0. It just cancels. X over 2 is equal to 6. Okay, so a number divided by 2 is 6. I might be able to do that in my head, but I'm going to show my work. Divide by 2, the opposite is multiply. I'm sorry, the inverse is multiply. X divided by 2, the inverse is multiply by 2. I'm going to put a dot. I'm going to use a dot. I'm not going to use an X. I'm going to use a dot. And the reason I'm using a dot is for simplification. Like, I don't want an X here and an X here, and my brain gets confused. I don't have to multiply, I only have to cancel off. Dot 2. 6 times 2 is 12. This X just comes down. That's it. 12 divided by 2 is 6, plus 3 is 9. That's my check. Okay, last one. One step or two step. I see two numbers, two operations, so I'm going to go with two step. What do I do first? Earlier I said that you're going to add or subtract first, and in this case I would look at it, but x plus 3 is all being divided by 2, and so really the 2 is a term without the x, the 3 is attached to the x this time. This is like saying a number plus 3 divided by 2. This is together, this is all one number. Okay, you can't combine it because it's not like terms, but it's all one number. So everything is divided by 2. I'm going to multiply by 2 first. They cancels. Divide by 2, multiply by 2 cancels. Inverse operations. X plus 3. You can put in parentheses if you want. It's the same thing. 6 times 2 is 12. Now, okay, that's one step. Do that in my head. X is equal to 9. Okay, 9 plus 3 is 12 divided by 2 is 6. All right, you may not subtract 3 off first. If you subtract 3 off first, you'll find that you have the wrong answer. All right,